Lesson 8, using if-then moves and solving equations. Let's begin. So, first, we need to summarize the if-then moves and discuss what they are. If a number is added or subtracted to both sides of a true equation, then the resulting equation is also true. If A equals B, then A plus C equals B plus C. We added C to both sides of the equation. If A equals B, then A minus C equals B minus C. We subtracted C from both sides of the equation. If a number is multiplied or divided to each side of a true equation, then the resulting equation is also true. If A equals B, then A times C equals B times C. If A equals B, then C and C does not equal 0, then A divided by C equals B divided by C. These are very, very true statements. We will be using them in solving multiple one-step and two-step equations. Write 3 plus 5 equals 8 in as many true equations as you can using the if-then moves. Identify which if-then move you used. Well, first, we could do if 3 plus 5 equals 8, then 3 plus 5 plus 4 equals 8 plus 4. Add 4 to both sides. This would be an example. Another example, if 3 plus 5 equals 8, then 3 plus 5 minus 4 equals 8 minus 4. Subtract 4 from both sides. If 3 plus 5 equals 8, then 4 times the quantity 3 plus 5 equals 4 times 8. Multiply both sides by 4. If 3 plus 5 equals 8, then 3 plus 5, the quantity, divided by 4, equals 8 divided by 4. So divide both sides by 4. That's another possibility of a true equation. Example 1. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, Keller had collected $42.50 more than Julie, and Israel had collected $15 less than Keller. The three firefighters collected $125.95 in total. How much did each person collect? And we want to find the solution using a tape diagram. Well, first, Julia, Keller, and Israel. Here's our tape diagram. Keller did $42.50 more than Julia. So we can physically see that extra amount over Julia. And then the same with Israel. Israel had collected $15 less than Keller, which makes it $27.50 more than Julia. That's where that $27.50 comes from. We took 15 and subtracted it from $42.50. So 3 units, because those 3 rectangles, we don't have any value in those 3 rectangles. So 3 units plus $42.50 plus $27.50 equals our grand total of $125.95. Well, if we look at this even further, $42.50 plus $27.50 equals 70. So we're going to subtract 70 from $125.95. If we do that, we get $55.95. So that means that the 3 units, those 3 rectangles, equal $55.95. So we're going to divide that by 3. Each individual rectangle equals $18.65. So how much did each person collect? They each collected $18.65. What were the operations we used to get our answer? Well, first we added $42.50 and $27.50 to get $70. Next, we subtracted 70 from $125.95. And finally, we divided $55.95 by 3 to get $18.65. Those are the 3 operations we used. We added, we subtracted, and then we divided. The amount of money Julie collected is J dollars. Write an expression to represent the amount of money Keller collected in dollars. Well, j plus 4250. Using the expressions for Julia and Keller, write an expression to represent the amount of money Israel collected in dollars. Well, we would have j plus 4250 minus 15, or we could simplify the 4250 minus 15 and get j plus 2750. So those would be our expressions for the three individuals. Julia is j, Keller is j plus 4250, and Israel is j plus 2750. Using the expressions written above, which on the previous slide, write an equation in terms of j that can be used to find the amount each person collected. Well, first we have j for Julia, j plus 4250 for Keller, and j plus 2750 for Israel. So all three of these added together, we get the equation equal to $125.95. Now we want to solve that equation. And we want to determine the amount of money each person collected and describe any if-then moves used. So first, we have our three quantities. We have our equation equal to $125.95. We're going to combine like terms, the any, order, any grouping. We're then going to subtract 70 from both sides. After we subtract, we do any, order, any grouping, additive inverse. The additive identity, anything plus 0 is itself, so we have 3j equals 5595. We then multiply both sides by 1/3 or divide both sides by 3. Both is completely acceptable. When we multiply by the multiplicative inverse, 1/3 times 3, it makes it a 1. So we have 1j equals 1865. And finally, Julia collected 1865. If that's the case, then Keller collected 1865 plus 4250, which is $61.15, and Israel collected 6115 minus 15 equals 4650. So how did we just get those answers? We used the initial. J is Julia. Julia collected 1865. Keller is J plus 4250. So we took the 1865 for J, added 4250 to get the grand total of 6115 for Keller. For Israel, here we went back to where we used Keller's and subtracted 15, because 4250 minus 15 is 2750. Let's say we didn't do this as the subtraction. We could have said, well, 1865 plus 2750, we would get 4615. It would still be the same. Example 2. You are designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. You decide that you would like the length to be 6 1/3 feet longer than the width. We want to draw and label a diagram to represent the pet pen. And then we want to write expressions to represent the width and length of the pet pen. So first, let's get a diagram. Here we have x for one side and x plus 6 1/3 for the other. So which one is which? Well, we decided that the length to be 6 1/3 feet longer than the width. So this must be the length. X plus 6 1/3 is the length. X is the width. So the width of the pet pen, x feet, then x plus 6 1/3 feet represents the length of the pet pen. Continuing, we want to find the dimensions of the pet pen. Well, let's look at the arithmetic first. We could have 30 minus 6 1/3 minus 6 1/3 and then divide it by 4. 17 1/3 divided by 4 equals 4 1/3. So for the algebraic, we have x plus 6 1/3 plus x plus 6 1/3 equals 30. Now as we take a look at this, what we're doing is we're combining like terms first, and then we are going to slowly solve this two-step equation. Our two-step equation is right here, the 4x plus 12 and 2/3 equals 30. We're going to subtract 12 and 2/3 from both sides. When we subtract that from 30, we get 17 and 1/3. So now we have 4x equals 17 and 1/3, and then we're going to divide that by 4, or multiply by 1/4. Dividing by 4 and multiplying by 1/4 are the same thing. So we take that value, we divide it by 4, and we get 4 and 1/3. So x equals 4 and 1/3. Notice the arithmetic and the algebraic, we get the same answer. So the width is 4 and 1/3. We plug that into our expression for the length. 4 and 1/3 plus 6 and 1/3 equals 10 and 2/3 feet. So our width, 4 and 1/3, our length, 10 and 2/3 feet. So the dimensions of the PET pen. If the perimeter of the PET pen is 30 feet and the length of the PET pen is 6 and 1/3 feet longer than the width, then the width would be 4 and 1/3 feet and the length would be 4 and 1/3 plus 6 and 1/3, which equals 10 and 2/3 feet. Example 3. So here's the problem, and then we'll show the problem. So Nancy's morning routine involves getting dressed, eating breakfast, making her bed, and driving to work. Nancy spends 1/3 of the total time in the morning getting dressed, 10 minutes eating breakfast, 5 minutes making her bed, and the remaining time driving to work. If Nancy spent 35.5 minutes getting dressed, eating breakfast, and making her bed, how long was her drive to work? Write and solve this problem using the equation. Identify the if-then moves used when solving the equation. Well, first, the total time of the routine is x minutes long. The total time is x minutes long. So 1/3 times x plus 10 plus 5 equals 35.5. Next, 1/3 x plus 15. We combine 10 and 5 to make 15. Next, we're going to subtract that 15 from both sides. After we do that, 15 minus 15 is 0, so we have 1/3 x plus 0. We wanted to get rid of that 15 from the left side. We're trying to solve for x. Our goal is to know what x equals. And so to do that, we subtract the 15 first. Then we need to get rid of this 1/3. So we multiply both sides by 3, or we can divide both sides by 1/3. So we multiply both sides by 3, and we find that x equals 61.5. So 61.5 minus 35.5 equals 26. So it takes Nancy 26 minutes to drive to work. Is your answer reasonable? Explain. Yes, it is reasonable. Why? Because some of the morning activities take 35.5 minutes, so the total amount of time for everything will be more than 35.5 minutes. Example 4. The total number of participants who went on the 7th grade field trip to the Natural Science Museum consisted of all the 7th grade students and 7 adult chaperones. 2/3 of the total participants rode a large bus, and the rest rode a smaller bus. If 54 of them rode the larger bus, how many students went on the field trip? Let's calculate this out. We're going to look at two approaches. We're going to look at the arithmetic and the algebraic. So first, the arithmetic. We have a diagram here. We have 4 boxes, 4 rectangles, and they're combined. They're separated by very, very small lines. First, we have the 2/3 on a large bus. That's 54. 1/3 on a smaller bus, 7. Total on both buses, 54 divided by 2. We're going to multiply that quantity by 3, 81. Where did we get 54 divided by 2 and then times 3? It was from the fraction 2/3. We took 54 and we divided it by the fraction 2/3. If you take 54 and divide it by 2/3, you get 81. a way you can do that by hand is we could technically do 54 times 3/2. Because whenever you're dividing by a fraction, it is the same as multiplying it by the reverse of that fraction, flipping it. So 54 times 3/2, or 54 divided by 2 and then times 3, we get 81. So total number of students, 81 minus 7, because we had 7 chaperones, equals 74. So there were 74 students that went on the field trip. Let's look at the algebraic approach. Number of students is S. Total number of participants is S plus 7. We have S students plus 7 chaperones. We start off our equation with 2/3 times the quantity, S plus 7, and this all equals 54. So to get rid of the 2/3, we multiply by 3/2 to both sides. So 3/2 times 2/3, that gets us 1. When you multiply 3/2 times 2/3, you're multiplying by multiplicative inverse. 3/2 times 2/3 equals 1, or reciprocal. So 1 times the quantity, S plus 7, equals 81. S plus 7 equals 81. We subtract 7 from both sides. When we do that, we get S by itself. We get S equals 74. So our first if-then move, we multiplied both sides by 3/2. Our second one, we subtracted 7 from both sides. And finally, we had 74 students that went on the field trip. Thank you so much for joining me on this. Have a wonderful evening.